Hello everyone, my name is Yang Hongbin. My project is Architectural Sketch to 3D model in CAD software. During the process of architectural design, architects usually start with sketch, brainstorming idea, and then they'll make 3D model and finally the real building. However, building a 3D model is time consuming and it also includes a lot of repetitive work. Although there are already some research about 3D reconstruction, none of them are suitable for this task. The ideal solution is to generate 3D object in the CAD software, which has a really fine shape and is easy for post-processing. To perform this, my idea is to train a transformer that takes a hand-drawn sketch as input, generate a scene parameter that includes all the objects in the scene. Then, we can program the 3D model software to generate a 3D model based on these parameters. I made two datasets, a simple one and a complex one. The simple dataset has only cube and cylinders and has less objects in each scene. The complex dataset has more objects and different types of shapes, and it also includes orientation. For the 2D image, I rendered multiple edge maps for each scene, and there are two types of them, where the more informative one shows a colored XYZ axis as well as the hidden lines. For the model architecture, basically it's an encoder-decoder transformer. The input is a single 2D image, and my plan was to use a sketch simulator to transfer the edge rendering into a sketch, but unfortunately I didn't have time to implement this part. For the encoder, I used DIET, Data Efficient Image Transformer, and the decoder is just a vanilla transformer decoder. For the output sequence, it first predicts the camera pose and then it will output the parameter of all the objects one by one, including the type of shape, position, orientation, and size. Let's see the result. This is the easiest dataset. The first row is the input image, and the second row is the reconstructed 3D model, and the last row is the ground truth. I will say the visual result is quite pleasing, that most of the objects are in the right place with the correct size. The quantitative result is also really good. Here's the result of the normal dataset, which has no hidden lines as well as the exit information. As you can see, the result is worse compared to the previous one, but at least the number of objects and the types of shape are correct. The value is also worse, but still I will say it works. Finally, the complex dataset. I think it completely fails. You can see the predicted result has nothing to do with the input and the ground truth. For the reason of failing, I guess maybe the scene is too complex for this model, or since the number of the objects and the size are increased, the occlusion may produce too much noise when training. Also, since the scenes are generated randomly, lack of context may also be an issue. These values are just disasters. In conclusion, I propose a transformer-based 3D model reconstruction method and prove its efficiency and accuracy with simple scenes, as well as a dataset for training this model. This is the end of my presentation. Thank you for your listening.